Hello everyone, welcome to National Defense Institute's PYQ series. Here we are going to look at the CDS 1 2022 question paper and we are going to discuss all the questions related to physics. So the first question, if the magnification produced by a lens is +2, then the image is. We are provided with 4 options. So immediately when we see the word magnification and lens, please think about the formula for magnification. Magnification of a lens is equal to mv by u, where v is the image distance and u is the object distance. Now we already know that u is always going to be negative. So u value will always be negative, whereas v value will depend upon the image formed by that particular lens. And by sign conventions, we know v is going to be a negative value, then the image formed will be virtual image. And if v value is going to be a positive value, then the image formed is going to be a real image. Alright, when we substitute both v and u as negative, the value of m automatically becomes positive. Right, m is equal to minus v by minus u. The minus signs gets cancelled out and we get resulting with an positive m. So the positive m shows that the image formed is going to be virtual. So here in the question we are given with a value called m is equal to +2. Always remember the plus sign, the sign whatever is in front of the numerical value, that denotes whether the image is going to be virtual or real. In this case it is virtual. And the numerical value, if the numerical value is greater than 1, then the image formed is larger than the object, and if the numerical value is less than 1, the image formed is smaller than the object. So using these two things, remembering these two things, we conclude the final answer to be option C, where we get an erect, virtual and larger than the object is the image formed by a magnification of +2, right? Next question. What is the current sequence of resistivity? What is the correct sequence of resistivity of silver, nichrome and glass at room temperature? So here resistivity is given. What do you mean by resistivity? Resistivity is the amount of resistance offered by a material, right? It is given as rho is equal to RA by L. And from this formula we know that rho is directly proportional to R. So with increase in resistance, resistivity also will increase, right? And from Ohm's law, what do we know? We know that I is inversely proportional to R, right? Remember Ohm's law, I am not stating the entire Ohm's law over here. V is equal to I into R is your Ohm's law. From this we get I is inversely proportional to R. So with increase in resistivity, the current will decrease, right? So that is how we sort out all the materials to be, all the elements to be, whether a metal, a non-metal, a conductor or an insulator. So by looking at the metals or substances given to us, silver, nichrome and glass, what do you understand? Obviously silver is a metal, right? And nichrome is an alloy. And then finally comes glass, which is an insulator, right? This is known to us just by looking at the metals. And what have we learned earlier? We have learned that metals are good conductors. So what does that imply? There is a lot of current flowing through the conductors. If more current flows, then the resistance is less. In turn, the resistivity is also less. So silver has the least resistivity, right? Followed by nichrome and then by glass. So the correct answer is option A. Question number 3. At the time of short circuit, the current in the circuit. What will happen during the time of short circuit? There are two kinds of circuits that are available for us. One is called open circuit. What happens in open circuit? You have a source. It can be an AC source or a DC source. Here I am drawing a DC power supply battery, right, which is connected to a switch. and it is in turn connected to a bulb, right? So this is called open circuit. Since I have kept the switch in open condition, there is no current flowing through it and the bulb does not glow. As soon as I close the switch, my bulb starts to glow, resulting in a closed circuit. So under open circuit, what will happen? Under open circuit, the current will be zero and voltage will be maximum, right? Voltage will be maximum. All our plug points are open circuits. Until and unless you go and plug in a device, current is not going to flow into it, right? You go, you poke inside it, then you get an electric shock. Until then, that is not doing anything for us. So all our plug points are open circuit where the maximum voltage is available. In order to represent maximum, I have used the symbol infinity. It does not mean infinitely large value is coming out. The maximum value is coming out, and for India the maximum value of voltage supplied is 220 volts, right? And the current through the circuit is zero. There is no current since there is no appliance connected, right? In the case of short circuit, what happens is that, what do you mean by short circuit? The battery, some default or something happens, right? So when I close the switch, some electrical defect happens and this bulb doesn't work. There is a direct connection from the battery to that of your positive terminal to that of your negative terminal, right? The tungsten filament that is present in the bulb, it may lose its property, it may get burnt out, something happens. The wire is directly connected. That is, you connect the positive and negative of the terminals directly using a single loop of wire. That is called short circuit. When short circuit happens, what is the condition is the current becomes maximum and the voltage becomes zero, right? This is the condition for open circuit and short circuit. By applying these conditions over to our question, we end up with an answer to be option C. It increases very heavily. Got it? Moving on, question number 4. Which one of the following statements is not correct? Such kind of questions you need to really take care of, because you need to understand whether they are asking you to find the statement which is correct or the statement which is not correct. First, get a clarity on it, right? So here we are supposed to find the statement which is not correct. Even if you are sure of the answer to be option A by reading it itself, please make a point to go through all the other options that is left in the question. This is very, very important, students. So make sure that you are reading all the options that is given to you. Over here, let us go option by option from A. An electric motor converts electrical energy into mechanical energy. Of course, this statement is true, right? This statement is true because electric motor's main working principle is conversion of electrical energy to mechanical energy. How do you remember this? Which energy is getting converted into what? How do you remember this? I will give you a simple example. When there is no water in your house, what do? You immediately go and switch on the motor. What is the motor doing? The motor is carrying the water from ground floor to top floor, right? So you are putting on the switch, which is an electrical energy. And what is the motor doing? Carrying water from ground floor to top floor, which is a mechanical work, right? So the electrical energy is converted into mechanical energy. Hence, that statement is true. Second statement, an electric generator works on the principle of electromagnetic induction. This is also true. Why do we say that this is true? How does the electric generator work? Electric generator is generating current. It is generating or it is producing current, right? When there is no power, we rely on the generator to produce the current. So over here, how does the current gets produced? We take two magnets, we place it inside a rotating armature, right? You have a rotating coil which is placed inside a magnet, very powerful magnet. What happens? Because of the rotation between the magnetic field, a current is produced, a current is induced, right? So hence the statement B is also true. right? What are we supposed to find? We are supposed to find the statement which is not correct. So moving on to statement C. The magnetic field at the center of a long circular coil carrying current will be a parallel straight line. This statement is also true, right? Magnetic field of a straight, for example, if your magnet is straight like this, then the magnetic field will be circular, right? And in the center it will always be straight for a bar magnet also. So in the same manner for a circular coil, the circular coil is nothing but your solenoid, which we would have learnt, right? So when I pass electric current through this coil gets magnetized and magnetic field lines are formed around this coil. Here also inside the coil the magnetic field lines are going to be straight and parallel to each other. Hence this statement is also true. Obviously the last statement has to be false, but let us give a valid explanation for this. Alright, the insulation has to be green in color for a live wire. That is not true, right? It can be any color. The insulation does not decide whether the wire is going to be a live wire or a neutral wire. You can have green color, you can have red color, you can have blue color, right? You can have any kind of color you want. Universally the color coding is done. For example, if you open any socket in your house, you will find that the red color wire is called live wire and the black color wire is called neutral wire. That is just for universal color coding, right? For example, if you are using an electrician for your house, you cannot rely on the same electrician coming to your house every day and checking whatever fault you have. So when you call in the next person, he should understand what kind of electrical connection is made, right? So universally the agreed color code is red to be live and black to be neutral and green to be earthing wire, but that is not the case. It can be anything. Insulation color does not depend upon the conductivity of the wire. Hence the answer is option D. Fifth question. A boy completes one round of circular track of diameter 20 meters in 30 seconds. What will be the displacement at the end of 3 minutes and 45 seconds? First, for this, let us draw the circular track, right? And the diameter of the track. The diameter, it can be from end to end. This is given as 200 meters, right? And let us assume the boy is starting from this point A. Okay. So when the boy goes around, he is running around the track, right? So when he is running around the track in this manner, he comes back to position A. That is called one round. So one round is taking 30 seconds for the boy to complete. Alright. Now let us go back to the definition of displacement. What does displacement tells? Displacement is nothing but the shortest distance between starting point and ending point. This is the definition for displacement, right? So what is the starting point over here? Point A. What is the ending point over here? That is also point A, because he has to complete a round, right? For a circle, the starting point, when you come back to the same point, it is going to be the point A only. So displacement at the end of one round will be 0, right? For the second round, the boy is running again. So it has become 60 seconds now. He has completed one round in 30 seconds. So for two rounds, he will take 60 seconds. And what will be the displacement at the end of two rounds? That will also be equal to 0, right? That will also be equal to 0. Now in the same manner, the boy is running for 3 minutes and 45 seconds. So for 3 minutes, how many rounds can the boy run? For 3 minutes, 3 minutes is equal to what? 3 into 60, correct? 1 minute is 60 seconds. So 3 into 60, that is equal to 1800 seconds. For 1800 seconds, the boy can run how many rounds? One round is 30 seconds. For 1800 seconds, the boy can run nearly 6 rounds, right? The boy is running 6 rounds in 3 minutes. So for 6 rounds, at the end of 6 rounds, what will be the displacement of the boy? That will be 0 because he is coming back to the starting point again at the end of 3 minutes. Now coming back to this 45 seconds. What will happen in 45 seconds? Let me split and write this 45 seconds as 30 plus 15. Why am I writing in this manner? Because one round is taking 30 seconds. Right? So the displacement at the end of this will be 0. Right? So this will be like 6 rounds plus 1. So for this 30 seconds, one more round. So the boy has gone now 7 rounds and the displacement at the end of 7 rounds is 0. Now coming to the last 15 seconds. This is where we have to be very careful. For the last 15 seconds, what happens? Let us assume the boy is starting from the point A. He is coming, 30 seconds is for one complete round. So at the end of 15 seconds, won't the boy be at point B? Agreed? Half of it, right? So he should cover half the distance. So the boy is starting from point A and he is coming to point B at the end of 15 seconds. Now coming back to the definition of displacement, shortest distance between starting and ending point. So draw a straight line. What is the distance between A and B? That is nothing but the diameter. That is nothing but the diameter. And what is the diameter given to us in the question? It is given as 200 meters. Hence the correct option is option C. Got it? Little bit tricky question. Please read the question, spend a few minutes and then proceed on. See, for the previous question and all, we did not spend a lot of time. So try to balance your time in this manner. For theoretical questions where time is very less, spend only 20 to 30 seconds for this. For questions of this nature where you have to really work out, spend at least 1 or 2 minutes, think it over, draw the diagram and then proceed. That will give you a very better and clear answer than anything else. Moving on, question number 6. What happens to the gravitational force between two objects if the mass of one object is doubled and the distance between them is also doubled? So what is happening here? I am doubling the mass of one object and the distance. Let us go back to the formula for gravitational force. Remember Newton's universal law of gravitation? F is equal to G m1 m2 divided by r square, where m1 and m2 are the mass of the two objects, right, and r is the distance between the two objects. So this is my universal gravitational law given by Newton, right. Now according to the question, what is happening? Mass of one object, let us assume the mass of one object m1 becomes twice that, right, it is doubled, so it becomes 2m1 and the distance between them is also doubled, so the distance r becomes 2r. Now what happens to the new value of gravitational force? F nu, let us call it, is equal to G, m1 is becoming 2m1, m2 is remaining the same because in the question it is given mass of one object, so we are taking only one object, and r over here becomes 2r, hence it is 2r the whole square. Students, please remember, most of you make a mistake over here, you write it as 2r square, it is not 2r square, it is 2r the whole square. Okay, so please be careful while writing such kind of things. Now taking out all the constants, 2g m1 m2 divided by 4r square, 2 and 4 gets cancelled out, I have a 2 at the denominator, it is 1 by 2 g m1 m2 divided by r square. Now this 2 m1 m2 divided by r square is same as the old one, so I can replace this as F nu will be equal to 1 by 2 F. So what is happening? The new force of gravitational is half the value of the old force. So what is the answer over here? What is the correct option that we have to select? The force would be halved. Okay, please, that is what I told. For theoretical questions, spend less time. For questions of this nature, work it out. Don't simply look at the questions and try to mark the answer. Write it out, write the formula, substitute it. Even if you are spending 1 or 2 minutes, it is fine. Think it over and then do it. Moving on, question number 7. An object weighs 9 Newton on the surface of the earth. What would be its weights when measured on the surface of a planet where acceleration due to gravity is 9 times that on the surface of the earth? Right? So let us write the formula for weight. Weight is equal to mass into acceleration due to gravity. Right? This is known to us. So what is given to us? Mass on the surface of the earth. Weight on the surface of the earth is equal to mass into gravity on earth. Right? For a planet. We don't know, right? For a planet only they have given. So we will put it as P. Mass into gravitation on that particular planet. Now students, over here what you need to note down is mass does not vary. Mass is constant wherever you go. Mass is a constant quantity wherever you go. You go to Earth, you go to Moon, you go to Jupiter, Saturn, Uranus, wherever you go, mass is a constant quantity. Mass of an object does not vary. What is mass? Mass is a amount of substance that is present in a material. Alright. So if you are carrying a substance, the mass of the substance won't vary wherever you go. So mass is a constant factor over here. Only the weight will vary. How does the weight vary? Weight depend upon gravity. Now writing weight on the earth divided by weight on the planet will be equal to mass into gravity on earth by mass into gravity on planet. Since mass is constant, mass will get cancelled out, and what is given to us in the question? Acceleration due to gravity on that planet. Planet is equal to 9 times acceleration due to gravity on earth. Right? So I am substituting this over here. Weight on earth by weight on planet will be equal to gravity on earth by 9 times gravity on earth. So gravity on earth gets cancelled out. Gravity on earth, there is a value. Gravity on earth is given as 9.8 meter per second square. You can substitute that value also, but anyway it is going to get cancelled out. That is why I am keeping it as a variable itself. I am not putting the numerical value for it. So what do I get it here? I get it as 1 by 9. From this, if I write weight on planet, that will be equal to 9 times weight on earth. Now weight on earth is given as 9 Newton. If you want, you can substitute that value, but that is not our options. Our option is not numerically given. If our option is given as, for example, option A is given as 18, option B is given as 81, option C is given as 27, then you can substitute the value and find out. Since this is not given, I am not going to substitute the value for weight on earth. So by looking at the options, I come to the conclusion that weight would be 9 times. Weight on that planet would be 9 times the weight on the earth. Understood? Spend a few minutes. Again, I am repeating the same point. Spend a few minutes for such kind of questions. Moving on. The twinkling of star is due to, right? This is a direct theoretical question which you should be familiar with. Twinkling of stars is due to the atmospheric refraction. Okay, atmospheric refraction of the starlight. As we all know, this is Earth. Earth is covered. Above the Earth's surface, we have how many layers? You would have learned this in your other subjects. We have 7 layers, right? Stratosphere, starting from your stratosphere, lithosphere, stratosphere, mesosphere, thermosphere, exosphere, ionosphere, like that we have 7 layers on the surface, above the surface of the earth. Surface of the earth till the space we have 7 layers. So what happens when there is a star? When light travels from that star and it falls on the surface, each surface is optically denser in different manners. Right? For example, mesosphere is the coldest layer. When something is very cold, the density is more. So it is optically denser. Right? So like that you have lot of layers. So for each layer there will be a refraction of light happening depending upon the density. Okay? Depending upon the density there will be a refraction happening. So that is called as your atmospheric refraction. This atmospheric refraction is also responsible for lot of other things. like your delayed sunrise, early sunset, right, or delayed sunset, early sunrise. It can be anything, delayed or early sunrise and sunset, right. This is also responsible for atmospheric refraction. Rainbow formation is also atmospheric refraction. The water enters into the sunlight enters into the water droplets that are present in the atmosphere. They get total internal reflection and comes out as rainbows, right. So all these things also depend upon your atmospheric refraction, right. Moving on. A convex lens has a focal length of 15 centimeter. At what distance should an object be placed in front of the lens to get a real image of the same size of the object? So what are we trying to achieve over here? We are trying to achieve the same size of the object. So what does that mean? Object size. Let me write it. Height of the image should be equal to height of the object, right. So this should happen. Height of the image should be equal to height of the object. When does this happen? We have to go back to our ray diagrams of convex lenses. So let me write object position, image position, right. We have different positions for this. I hope you all remember all these things. For example, this is your principal axis, this is your lens, this is the optic center O point. You have your F1, right, 2F1, and this side we have F dash or F2 we call it, or we call it as 2F2 or 2F dash, right. This is the image formation. So if I keep an object at infinity, I get my image at F. These are the 6 different cases of your image formation in a convex lens. This we should be thorough at, right. Then we keep it beyond. What is the second case? We keep it beyond 2F1. Where do we get the image? We get it between F2 and 2F2. This is where we get the image. Next, what is the case? These are the different positions. I hope you people are able to receive it. We keep it at infinity. This is first position. We keep it at 2F2. This is the second position. We keep it at 2F1. This is the third position. For this, you will get the image over here, right, for the first position. Second position, you will get it here. Third position, you will get it here, right. So when you keep the object at 2F1, you will get the image at 2F2. Now for this case, the object height will be equal to the image height. This is known to us from the ray diagram table, right. So where should I keep my object? I should keep my object at 2F1. F value is given as 15 centimeter. So what will be 2F value? 2F value will be equal to 2 into 15, that is equal to 30 centimeter. So if I keep my object at 30 centimeter, I will get my same size as that of my object. My image size will be the same size as that of my object, right. Understood? For this, we should remember the image formation tabular column of your convex lens, right. We have come to the conclusion of your CDS 1 2020